When we talk about building powerful AI, we almost always focus on what it can do. But today, we're going to flip that around and talk about something that's maybe even more important: how to make it stop. We're talking about emergency control design. The big red button, the kill switches that absolutely have to work when everything else has gone sideways. So let's start with this fundamental truth right here. And look, this isn't about being a pessimist. It's about being a realist. The fact is, complex systems, especially AI, are going to run into situations their creators just never saw coming. It's inevitable. So, planning for failure? That's not a weakness. It's literally the hallmark of smart, responsible engineering.
Okay, so why is this such a big deal? Let's get into why these control systems often fail and why getting the design right from the get-go is, well, it's completely non-negotiable.
It all boils down to one thing, really: time. Think about it. In a factory, or a critical lab, or really any high-stakes environment, a tiny little glitch can spiral into a full-blown disaster in just a matter of seconds. And that's the key, right? The real danger often isn't the initial failure itself. It's the delay. It's how long it takes us to react. And that brings us to probably the most important distinction in this entire conversation. You have to understand the massive difference between normal system governance and a real emergency stop. They're two totally different things, and confusing the two, that can be a catastrophic mistake. So let's look at a typical control plane. This whole thing is built for one purpose: order and process. You've got your control plane at the top for policies and approvals, then the execution plane in the middle, that's where the AI actually does its thing, and at the bottom, an audit plane to keep track of it all. The whole setup is designed for changes that are managed, predictable, and, you guessed it, governed. Okay, so that's governance. What's an emergency control, then? It's a safety mechanism, period. Full stop. It is not just another step in some workflow. It's not a request that goes to a manager for review. It is absolutely not a governance gate. It's a direct, immediate intervention that is built for one reason: to stop the system. Right. Let's break this down even simpler. On the left, you've got escalation. That's part of the normal process, right? It's about routing information to a human so they can think about it and make a decision. But an emergency stop, on the right, that is the decision. It's not asking for one. It just halts the system immediately. Both of these are super important, but they do completely different jobs. Okay, let's jump back to our diagram to see how this plays out. This path you see highlighted in amber, that's escalation. And notice where it is. It's working inside the control plane. See how it snakes through all the validation checks and heads right up to the approval gates? It's playing by the rules. It's following the governance playbook. Now check out the red path. The difference is just stark. This is our emergency stop. And look where it comes from: a completely separate emergency rollback authority. It just leaps over all of those approval gates, all of the change control stuff, and slams the brakes directly at the execution level. It's designed to operate completely outside and really above the normal workflow. And this quote right here, it just nails it. This is the thing to remember. If your emergency brake has to get approval before it can be used, well, then it's not an emergency brake, is it? It's just another piece of red tape that's going to fail you when you're under pressure. Okay, so we get the what and the why. Now how do we actually build this thing? Let's get into the practical design of this essential bypass. So here are the core principles for any good kill switch. These are absolutely non-negotiable. First, it's got to be immediately accessible. I'm talking right there, not buried 3 menus deep. Second, it has to be unambiguous. When you hit that button, there should be zero confusion about what's going to happen. And this last one is critical. It has to be independent of the system it's supposed to be controlling, because you need it to work when that very system is what's failing. I'm going to say this again, because it is the single biggest mistake people make. If your emergency stop needs an approval to work, you haven't designed a safety measure. You've just designed another business process. And that process is exactly what will cause a fatal delay when a real crisis hits. Right, but not all AI systems are created equal, you know? And that brings up a really important point. The more power you give an AI, the more robust its emergency controls have to be. They're directly connected. And logic here is pretty simple. If you have an AI that's just assisting people, making recommendations, then a standard escalation path might be fine. But what if the AI starts shaping decisions? Well, now you need a way to halt its influence, and fast. And if that AI is actually influencing execution, it's in there making changes to a system on its own, then you need an immediate, no questions asked kill switch, no debate. So what happens when people get this wrong? Well, let's look at some of the painful lessons we've learned from real-world failures.
When you read the postmortems on these kinds of incidents, you see the same mistakes over and over again. Things like, yeah, there was a kill switch, but it was buried on page 57 of a procedures manual. Or, stopping the system required 3 levels of managerial approval. Or, nobody was actually sure who had the authority to pull the plug. And maybe the saddest one of all, the operators, the people on the front lines, were never even trained on how to use the safety controls.
Okay, before we wrap up, I need to make something crystal clear. What we've gone through here is a framework. It's a set of principles to help you think about and design for safety from the very beginning. But what this is not is an authorization or a stamp of approval for any specific system to be deployed. The goal here is simple: to give you and your teams the mental tools you need to build AI that can be stopped safely and reliably when it matters most. When you boil it all down, this whole conversation comes back to one really powerful idea. The only way we're going to truly trust AI isn't just by making it more powerful, but by making it provably safe.
Building a big red stop button isn't about being cynical or not having faith in your own tech. It's actually the opposite. It's a sign of maturity. It's a sign of professional engineering. It shows a deep respect for just how complex these systems are, and an acceptance of the simple reality that sometimes unexpected things are going to happen. So I'll leave you with this question. As we continue to build AI that is more and more powerful, where is that real foundational trust going to come from? Is it going to come from the AI's raw power, or is it going to come from the absolute certainty that there is a well-tested, totally reliable, and easy-to-access way to make it stop? Something to think about. Thanks for tuning in.